Now let's talk about oxides. So far we have talked about acids, bases, and alkalis. Now the next thing would be oxides. Now what is the meaning of oxides? Oxides basically is a compound of oxygen and another element. So for example, sodium oxide is an example of oxide. Sodium oxide, the chemical formula is Na2O. So Na2O is an example of oxide. Another example would be sulfur dioxide, SO2 is another example of oxide. Okay, there are 4 types of oxide. The first type of oxide is acidic oxide. Now, what kind of substance is considered an acidic oxide? An acidic oxide is formed whenever a non-metal reacts with oxygen. Okay, an example of non-metal would be sulfur. So when sulfur reacts with oxygen, sulfur dioxide is formed. So sulfur dioxide is an example of acidic oxide. So whenever you have a non-metal, in this case is sulfur, and oxygen combined together, that is called an acidic oxide. Most acidic oxides are soluble in water to form acid. Okay, so these 2 points are very important. And then the next point is acidic oxide react with bases or alkali to form salt and water. Pretty much like acid and base react together to form salt and water. So instead of acid react with base, so now is acidic oxide react with base to form salt and water. So acidic oxide, just remember, non-metal and oxygen combined together, that would be acidic oxide. An example is sulfur dioxide. Non-metal is sulfur, oxygen, and then combined together, it forms acidic oxide. Now, there is an exception here. Okay, over here we say that most acidic oxide are soluble in water to form acid, but there is an exception. So silicon dioxide. Okay, your silicon dioxide is an example of acidic oxide because silicon is not a metal and then combined with oxygen. So your silicon dioxide is an acidic oxide, but this silicon dioxide does not dissolve in water, or it is insoluble in water. So even though we say most acidic oxides are soluble in water, but this is the exception. Silicon dioxide is actually the chemical name for sand. So sand, the sand in the beach, they are it is also called silicon dioxide. And of course sand does not dissolve in water. Now let's look at basic oxide. Basic oxide, so for acidic oxide is non-metal and oxygen combined together. Basic oxide would be metal combines with oxygen. Okay, an example would be copper oxide. So copper oxide is an example of basic oxide. Okay, iron 2 oxide is also an example of basic oxide because copper and iron, they are metal. So metal combined with oxygen, basic oxide. Most basic oxides are insoluble in water. Okay, and then basic oxide reacts with acids to form salt and water. Same, okay, this is actually the same with acidic oxide. Acidic oxide reacts with bases or alkali to form salt and water. So for basic oxide, it reacts with acid instead of base to form salt and water. So acidic oxide behaves quite similarly with acid. Acidic oxide behaves quite similarly with acid. Okay, why? Because acid also react with base to form salt and water. And likewise for basic oxide, it behaves quite similarly with base. Why? Because base react with acid to form salt and water. Okay. Okay, most of the basic oxide insoluble in water. Exception would be group 1 and group 2 oxide. Group 1 and group 2 basic oxide. So these are actually soluble basic oxides, would be group 1 and 2. Group 1 and 2 basic oxide, they are soluble in water. The rest of the basic oxides are not soluble in water. Okay, then the third type of oxide is amphoteric oxide. So just now we talked about acidic, basic. This is amphoteric. So amphoteric is both acidic and basic. So amphoteric oxide, it's a metallic oxide which react with acid and base to form salt and water. So amphoteric oxide has the property of acidic oxide and basic oxide. Because acidic oxide react with base to form salt and water, and basic oxide react with acid to form salt and water. So amphoteric basically is has both the acidic and basic oxides property. And for amphoteric oxide, there are only 3 examples. There are only 3 such amphoteric oxides in our syllabus. The first one is aluminum oxide, second one is zinc oxide, and the third one is lead 2 oxide. Why is there 2 there? Because lead can have lead 2, can have lead 4. This one is lead 2 oxide. Lead and then bracket II oxide. Now the fourth type of oxide is neutral oxide, and from the name, neutral oxide basically is neutral, doesn't react with base, doesn't react with acid. Okay, and this actually is not hard to remember. Okay, the examples would be carbon monoxide, nitrogen monoxide, water. Okay, they do not react with either acid or base, and they are insoluble in water. So that would conclude the types of oxide, 4 types of oxide. So you need to know, for example, basic oxide, what combined with oxygen would form basic oxide. Acidic oxide, what combined with oxygen would form basic acidic oxide. So acidic oxide is non-metal and oxygen. Basic is metal and oxygen. Amphoteric, just have to remember these 3 examples. And neutral, these few examples you need to remember. Now let's go to the pH scale. Acid and alkali. Now the strength and concentration of acid and alkali. Strength and concentration are 2 totally different things. So far we talk about the concentration of acid, for example. For example, the concentration of HCl. Okay, an example would be 100 gram per dm cube HCl. This is actually concentration. So this is considered very concentrated, 100 gram dm cube HCl. Now this is concentration. That means how much of the substance is dissolved in water. That is concentration. How about strength? Strength basically is how easily an acid or alkali dissociates or ionizes when dissolved in water. For example, HCl. Previously we talked about HCl. When it dissolves in water, almost all the HCl molecules dissociate to form H plus and Cl minus. So if almost all the HCl molecules dissociate to form H plus, the hydrogen ion and the chloride ion, that means HCl is a strong acid. So the strength of acid depends on how easily the acid dissociate in water to form ions. Okay, so in this case, the concentration of H plus ion in the HCl solution is very high, so HCl is a strong acid regardless of how high or low its concentration is. So even though if we dissolve only 0.001 gram of HCl in 1 dm cube solution, okay, even though if we dissolve 0.0001 gram per dm cube of HCl, that means even though the concentration of the HCl solution is very dilute, but still HCl is a strong acid. Okay, I repeat, even though the concentration of HCl is very low, for example 0.0001 gram per dm cube, HCl is still a strong acid. Why? Because whether or not the acid is strong or weak depends on the nature of it, depends on the behavior of the acid, and in this case HCl will dissociate very easily in water to form H plus and Cl minus ions. So it is a strong acid even though the concentration is very low. So for HCl, even though the concentration is very low or very high, HCl is still a strong acid. It is the same for sulfuric acid, H2SO4. It is the same with nitric acid. So all these are strong acid regardless of whether or not it is very concentrated or diluted. Okay, so this is a very important definition. How easily an acid or alkali dissociate when dissolved in water. That would define the strength of the acid, strong or weak. Likewise for alkali, strong or weak alkali. Now the calculation of the pH of acid or alkali solution, it is the calculation actually based on the relative numbers of hydrogen and hydroxide ions in the solution. When there are a lot of hydrogen ions in the solution, then the pH would be very low. That means it would be very acidic. So if a solution is very acidic, that means there are a lot of hydrogen ions present in the solution. Okay, if you look at your textbook, page 155 of your Discovery Science textbook, you can see this diagram here. Let's look at the legend of the diagram. The red dots represent the hydrogen ions and the blue dots represent the hydroxide ions. Now when the pH of a solution is 7, that means neutral, the number of hydrogen ions and hydroxide ions are almost equal. Now when the pH of a solution is 1, that means it is very acidic. We can see that the hydrogen ions, the concentration of the hydrogen ions are a lot. Okay, all of the ions here are red. That means hydrogen ions. And likewise for alkali, for strongly alkali solution, we can see that almost all the ions are hydroxide. Okay, let me move this textbook to the right hand side a bit. Yeah, over here you can see that almost all the ions present are the hydroxide ions. So the pH of a solution depends on the concentration of the hydrogen ions as well as the hydroxide ions. If the concentration of the hydrogen ions is very high, that means the pH of the solution would be very low, meaning that it is a very acidic solution. If the pH of a solution is, if the ions present are mostly hydroxide ions, and it means that the concentration of the hydroxide ions is very high, and it means that the solution is highly alkaline. Okay, so this part will take care of the pH of a solution. Depends on the concentration of the hydrogen ion as well as the hydroxide ion. So for example, hydrogen chloride, for example, hydrochloric acid. Hydrochloric acid, the pH would be 1 or 2. Okay, it is highly acidic. Why? Because it is a strong acid. Because almost all of the hydrogen chloride molecules, when they dissolve in water, they become ions, hydrogen ions, H plus, and chloride ions, which is Cl minus, and that is why the pH is very low. Okay, now let's take a look at the application of the pH. Now, most plants grow best in soil that is neutral or slightly acidic. Now, in many parts of the world, the soil is very acidic. So what the farmers do is they neutralize the acidity of the soil by adding quicklime or slick lime. So quicklime is calcium oxide, slick lime is calcium hydroxide. Okay, both, so your calcium oxide and calcium hydroxide are alkali, so they can actually react with the acid and neutralize the acid through the neutralization reaction. Okay, acidic soil is treated or added with quicklime and slick lime to neutralize the acidity. And then the indicator, the pH indicator, so you have to remember the methyl orange as well as phenolphthalein. These two are solutions. They are used to measure the acidity or the alkalinity of a solution. So for methyl orange, you need to know that the color of this solution in red, in an acidic solution it is red, and the color of the solution in alkaline solution is yellow. Same thing with phenolphthalein, colorless and pink. So phenolphthalein, methyl orange, you need to know the colors of their colors in acidic and alkaline solution. And for this part would belong to the pure chem students. And with that would conclude the acids and bases lesson. And remember to download the worksheet. Try to do the worksheet. If you do not know how to do the worksheets, try to refer back to this video. And with that, thank you.